Get that pallet secured. Copy that. Moving now.
This toolpath sequence on the z-axis looks too aggressive.
I agree. We need to optimize the G code for that curve to prevent chatter.
Code released. The machine should initialize now.
There's the green light. We are ready to begin.
Secondary machining. A smaller, high-speed drilling machine adds multiple ventilation ports and wire routing channels to the arm's chassis shell.
Vibratory deburring. Small end effector parts tumble rapidly in a drum of smooth ceramic media to achieve the required edge break.
Gear hobbing. The heavy, oil-lubricated gear hobber cuts the precise helical teeth profile onto a large ring gear. Heat treatment. Clean, finished gears are stacked inside a metal basket and loaded into the sealed vacuum furnace. Temperature stabilization is confirmed. The profile looks good. Lubrication system. A calibrated, automatic pump injects a pre-measured volume of white synthetic grease into the final gear set casing. 32. Subassembly lock. The motor and gearbox modules are held in a rigid jig. A technician uses a long-handled torque wrench to tighten the coupling bolts.
Main frame fixturing. The primary arm shells are manually lifted onto a large, floor-mounted assembly jig.
Weld start. The laser beam ignites with a controlled light flare. The torch moves at a steady, perfect speed, fusing the two sections of the main arm shell.
Localized stress relief. An induction coil clamp is placed around the fresh weld to apply slow, controlled heat for post-weld stress tempering.
Magnetic particle inspection, or MPI. The technician sprays a fluorescent powder, a handheld yoke.
Base plate mount. A standard front-driving electric pallet jack moves the arm base section to its final assembly.
Internal wiring feed. Technician uses a flexible plastic guide to pull the large, bundled control cables through the arm's internal access ports.
Cover panel fit. The final composite access panels are secured with small, color-coded quick-release fasteners.
The wireless digital torque wrench ensures accurate tightening of all fasteners, simultaneously logging the data to the tablet for verification.
The large, pre-wired electrical enclosure is positioned next to the arm and bolted securely to the floor with anchors. Main processor slot. Technician, wearing all grounding gear, carefully slots the main motion control CPU board into the cabinet's backplane.
Terminal connect. Wires from the arm are connected to labeled, color-coded terminal blocks inside the cabinet using a small, specialized screwdriver.
Homing sequence test. The robot performs a slow, controlled sequence where each joint moves to its mechanical home position and records the encoder value.
Safety scanner activation. The floor-mounted safety laser scanner is initialized, projecting a visible red zone around the arm's perimeter. Dynamic calibration. The arm executes a rapid, jerky motion test to measure and tune the responsiveness of its servo controllers. Final casing seal. Rubber and polymer seals are checked. The final access panels are locked down, confirming the arm's environmental sealing. The harmonic oscillation is well within acceptable limits. Tool change demo. The arm performs a rapid, controlled tool exchange, releasing a gripper and picking up a spot welding gun from the rack.
Final surface cleaning. Technicians wipe down the entire arm with non-abrasive, static dissipating cleaner, and the arm is gently lowered onto a custom-built, shock-absorbing wooden skid using a small mobile gantry crane.
Tension looks good on this side. Ready to crimp the steel banding.